The moon's surface has millions of craters, but something else has drawn a lot of attention to it. A giant rare hole that turned out to be a tube. It was found when the Japanese lunar orbiter was gathering data around the moon's skylight, the tube's entrance. Researchers found a specific echo pattern that suggested there was a hollow area. They discovered more echo patterns at a couple of places near the hole, so there could be more lunar tubes there. But in this big tube, you could place an entire football field and the pit could swallow it whole. It's irregularly shaped and 427 feet in diameter. Scientists think that there could be secret caves, a tunnel system, or an entire geological wonderland under the surface. It could be a good shelter for astronauts that land on the moon, or even be a harbor for a lunar colony. No one ever managed to stay on the moon for more than 3 days because of the conditions on the satellite. It has a wide range of temperatures, low atmosphere, and no magnetic field that would protect life on the surface from things like radiation or harsh sun rays. Astronauts wear spacesuits, but they can't protect them over long periods of time. But a lava tube could. When a lava flow cools, it gets a hard crust, which later thickens and creates a roof over that same lava. It continues to flow, but when it stops, the channel can drain, which results in an empty tube. Our planet also has lava tubes, but they're not as big as the one found on the moon. There's a special type of tree called a moon tree. It's grown from seeds that were taken into space during one of the missions and then returned back to Earth. You can find this kind of tree growing across the US. Earth is 27% bigger than the moon and far more massive. Our gravity is stronger. If you drop a rock on the Earth, it will fall faster. 150 pounds on Earth is just 25 pounds on the moon. The Earth has numerous satellites circling around it, but the moon is the only natural one. Our moon was formed during a big collision of the Earth and one more planet the size of Mars. This happened around 4.6 billion years ago, shortly after the Sun and our solar system were formed. After the collision, a cloud of vaporized rock went into orbit around our planet, cooled, and shaped into a ring of small solid bodies. They later got together and became the moon, leaving craters as a reminder of this collision. If you're standing on the surface of the moon, your shadow will be darker than on Earth. This is because there's no atmosphere to scatter light and create lighter shadows. One of Jupiter's moons, Io, has hundreds of volcanoes and pretty wild eruptions, sometimes sending plumes 250 miles into the atmosphere. These eruptions happen because of the extremely strong gravity this moon is exposed to. Its insides tense up and relax in those periods when it gets closer to and then further from Jupiter, which generates enough energy for insane volcanic activity. It's not just planets, even quite small space bodies sometimes have moons. In 1993, researchers discovered a 20-mile wide asteroid and its 1-mile wide moon. You'd need 400,000 moons to match the brightness of our central star, the Sun. The moon reflects the light it gets from the Sun, but it doesn't produce its own. That brightness depends on the angle between the moon, the Earth, and the Sun. Our moon is around 32 Earths away from us, and 29 Earths at its closest. When the night is dark and clear, it seems like you can touch a full moon. But if you wanted to do it, you'd have to travel up to 250,000 miles. Still, there is water on the moon. Not puddles or lakes, but grains of water ice exist in permanently shadowed parts near the moon's poles. Scientists think that water got on the moon a long time ago, during a period when both the moon and Earth were constantly struck by asteroids and comets, which contained water ice. This process may have even helped us get our own lakes and oceans, not just the moon's icy water. Newer research says that the moon's interior already had water, and it went to the surface during volcanic activity. The same might have happened on our planet too. Out of 200 moons in our solar system, our moon is the 5th biggest one. Jupiter's moon Ganymede is the biggest one, almost 1.5 times bigger than ours. Apollo 11 was the mission where humankind first landed on the moon. It was a very important moment, broadcast all over the world. But it was almost interrupted by a huge windstorm that was going on in Australia back then. Parker Dish was placed there, which was something we used to get the broadcast signals from the moon. The moon is not a perfect circle. It's more in the shape of an egg, with the thicker end pointing toward us. This shape is derived from its rotation. A full moon can keep you awake. Studies showed that people experienced less deep sleep, and it took them longer to fall asleep during the full moon period. It wasn't about its brightness, but the lunar cycle that influences our internal body clock. Each year, the moon is moving away from Earth because of the interaction between the moon's gravitational force and our oceans. In 1 year, it moves around 1.5 inches away, which means that in around 600 million years, it will be 14,600 miles further from Earth than it is now. This number isn't accidental. That's the time when total solar eclipses will stop happening. Humankind hasn't set foot on the moon in a few decades, but footprints there are still fresh because there are no winds up there, so these tracks can stay there for millions of years. Okay, show of hands. Who still believes that the sun goes around the Earth? Nobody. Oh, but everybody used to. It sure looks like it does. The sun comes up in the east, the sun goes down in the west. The sun comes up in the east again, so the sun goes around the Earth. It seems intuitively irrefutable, and it is so. But it's not true. The sun doesn't go around the Earth. Everybody knows that, but only now. So why do people still believe the moon goes around the Earth? It's not true either. We have to go back over 500 years to begin to get an idea of how hard it is for science to change universally accepted facts. Nicholas Copernicus, around 1510, was the first to propose a heliocentric, sun-centered solar system, but he didn't do it publicly. Copernicus privately circulated letters to other astronomers explaining why the accepted fact of an Earth-centered solar system should be scrapped in favor of a more straightforward, more astronomically correct, sun-centered solar system. Copernicus's difficulty in promoting the sun-centered solar system depended on another bold conceptual innovation, that the Earth rotates. Copernicus's concept of a rotating Earth flew directly in the face of 5 literal statements in the Bible that the Earth was founded on a fixed foundation never to be moved. And the Catholic Church wasn't about to let that worldview be challenged or changed. Copernicus had too much to lose to go public with his revolutionary, pun intended, heliocentric theory as a churchman himself. 100 years later, Galileo Galilei wasn't so reticent. Galileo had observational proof to back him up because he had a telescope. In early 1610, Galileo first observed the moons of Jupiter and kept track of their orbits. Yes, the moons of Jupiter do orbit around Jupiter. They go round and round the giant planet in actual orbits, unlike, as we shall soon see, how our moon travels around the sun with the Earth. Galileo became famous, or infamous, as the case may be, because he discovered orbital motions that were not heliocentric, that did not fit the accepted worldview. It rattled civilization's Earth-centered cosmology. Galileo was indeed revolutionary. Later in 1610, Galileo observed through his telescope, which only had an aperture of 1.5 inches, the planet Venus going through phases, just like the moon goes through stages. Galileo wrote that Venus imitates the moon, in Latin, in his notebook. There could be no other explanation for these observations. Venus was orbiting the sun. People were afraid to look through Galileo's telescope when he set it up in the Great Square of Pisa. They were too scared to have their worldview revolutionized. Strange as it may seem, we are experiencing something similar to that now concerning the moon orbiting the sun and acting like a double planet with Earth. People, scientists included, stubbornly persist in viewing the moon as its clever official International Astronomical Union name. It's a moon of the Earth, orbiting around the Earth, showing its different phases throughout the lunar month, or moonth, as moon fans sometimes like to call the 29.5-day cycle of lunar phases. Moon lovers' favorite day of the week, of course, is Moon Day. It comes right after Sunday. But back to the science. It's how our school books portray the phases of the moon. It's what people believe now. Notice how the Earth is the moon's center, and how it goes around the Earth in a circular path. This is the geocentric view of the moon. It's what we see from Earth. The moon comes up, the moon goes down. The moon comes up again. The moon goes around the Earth. But that's not what's happening in space. It's way past time we Copernicus-size the moon. We need to start seeing the moon from a heliocentric point of view, as we do for everything else in the solar system. First of all, the geocentric view of the moon's phases shows the Earth stationary, sitting in the center of the moon's path for a whole month. But the Earth is not stationary at all. We're zooming around the sun at a very high speed, anywhere between 66 and 68,000 miles an hour. Therefore, any picture of the moon going around a stationary Earth is profoundly misleading and really outright wrong. The heliocentric view of the Earth and moon moving together in space should look something like this. Notice that the moon is not going around the Earth. It's traveling along with the Earth, around the sun. The path of the moon around the sun is a sinusoidal path back and forth, across the ever-forward moving path of the Earth. Notice that the moon always goes forward too. It doesn't ever go backward to either the sun or the Earth. By always moving forward and sinusoidal, the path of the moon does not qualify as an orbit in the same sense that the other moons of the solar system orbit their planets in elliptical paths. Therefore, it is wrong to say the moon orbits the Earth. The moon orbits the sun along with the Earth, or the moon and the Earth both orbit the sun, are statements Copernicus and Galileo would approve of. But science today has difficulty accepting a heliocentric view of the moon. Maybe there would be too many books that need to be reprinted. That's one small step for man, one giant leap for mankind. Something Neil Armstrong, the first human that set foot on the surface of the moon, said. He was there with Buzz Aldrin, spending 2.5 hours on the lunar surface. Preparation for this project took a couple of years, and all the equipment the astronauts carried weighed over 170 pounds. It wasn't easy to land on the moon. There were lots of attempts in history that ended in failure. For example, astronauts in one of the Apollo programs had enough fuel to rocket people to the lunar surface in a mere 3 days. But they wanted to save on fuel, so it took them over a month to get there. There's no GPS to tell you where exactly to land. The spacecraft travels fast, and it has to slow down in a vacuum with not enough information. But since 1969, 12 people have already walked there. The moon is the only space object humans have visited so far. The rest have only been visited by robots. But all these people were just there for a short visit. NASA announced their program to work on a permanent presence on the moon. That would help scientific research and could be a good point to learn how to do the same on other missions, like the one on Mars. Imagine being the 13th person going to the moon. Scary silence, moon dust under your feet, and nothing but an endless black sky with stars all over you. But you have no time to admire the view. There are many issues you'd need to figure out before landing. First of all, our bodies are like machines that are adapted to conditions on Earth, like gravity, atmosphere, the air we breathe, and the food we eat. Our planet is where we function optimally. Our gravity is 6 times stronger than on the moon, which is, compared to our planet, almost a vacuum. Whatever you do, it wouldn't be smart to hold your breath in such conditions. The vacuum would pull the air from your body. Oxygen still present in your body would expand together with bodily fluids. They would push against the blood vessels and organ tissues. Your body, legs and arms, they would all lose their current shape and would bloat like a balloon to twice their normal size. If you stayed like that for a longer time, you wouldn't survive. But you wouldn't explode. Your skin is pretty elastic, and it would hold your body together. Liquids that are exposed to your body would evaporate. The surface of your eyes and skin, it would all boil. Saliva would literally boil on your tongue, but the blood would still be liquid. The walls of the vessels would protect it from boiling. No atmosphere, no oxygen either. The oxygen that's already in your lungs would quickly be gone, and you'd have nothing to breathe in. If your organs stopped getting oxygen, usually delivered to different parts of your body by blood, you'd pass out because your brain would shut down. It would happen in the first 15 seconds. That's how much time your body has to use the remaining oxygen in the blood to keep the brain functioning. Stay like that for a longer time, and bye-bye. No ozone layer, no strong magnetic field. The atmosphere of the moon is similar in density to those uppermost layers of the Earth's atmosphere, where we have the International Space Station. That means your body would be exposed to all those dangerous ionizing radiations from outer space we can't feel now because layers surrounding Earth keep us safe. On Earth, our muscles and bones are tuned to resist gravitational force. Without gravity, we'd start losing muscles, and our bones would become weaker. It's like with the blobfish, a marine creature that looks like the saddest animal on Earth. This fish lives deep down in the ocean. When down there, it looks like most other fish, just slightly scarier. But when it's out in the fresh air, it becomes flat, and its entire body looks like some weird, sad pudding, all due to differences in pressure. The moon would make you look like a blobfish because of drastic changes in atmospheric pressure. There's no pressure that would hold your body together. While on Earth, a column of air presses an approximate mass of 15 to 20 tons on the entire surface of your body. We don't notice this because this air pillar presses the body equally from all sides. There's air inside your body too. Internal pressure is the same as the atmosphere. And on the lunar surface, there's no pressure from outside to back it up. It's also really cold up there. Temperature drastically changes from 250 degrees Fahrenheit during the day to negative 208 degrees Fahrenheit when it's night. A day on the moon lasts 29 Earth days. That means you'd be spending 14 and a half days in unbearable light, and the next 14 and a half days in scary cosmic darkness.
It's 2065, and you're standing on the moon's dusty surface, working away on the latest array of solar panels to help fuel the local town's energy grid. Suddenly, the surface begins to shake. Is this a moonquake? Or are those moon-born teenagers having a party in the town hall again? You look up at Earth. You're so used to it, you barely even notice it anymore. But now, it looks different. It takes you a few moments to work out why. It appears to be shrinking. You begin to panic. The Earth is moving away. The ground rumbles again, and you work out what's happening. The Earth isn't moving, but what you're standing on is. The moon has broken off its orbit and it's heading out into deep space. Destination unknown. The strange thing is, it's happening right now, and has been for a very long time. It's even affecting how long our days are. Eventually, it will pull away altogether and dramatically affect our planet's oceans. To explore what will happen, let's go back a little, to put it all into perspective. The moon has been hanging around us, literally, for 4.51 billion years. There are a few theories as to how the moon came into being. The main one is that it formed when a large object smashed into the young Earth. The early solar system was a chaotic place. A number of stellar bodies were created that didn't make it into a full planet. One of these bodies, as large as Mars, smashed into Earth, throwing huge chunks of our planet's crust into space. Gravity took over and tied these separate elements together. This explains why the moon is made of lighter particles than we find here on Earth. Billions of years later, and we're more than used to having the moon with us. It affects so much of our everyday life. The obvious one is tidal motion. The gravitational pull or tidal force that the moon exerts on our planet creates the tides. This force causes all of the water on the Earth's surface that's closest to the moon to bulge out to one side. A very short explanation is that it pushes in from the top of our planet and also the bottom, while pushing out from the sides at the same time. The Earth also has an effect on the moon, which we'll get into in a minute. But it appears that the moon might not like our company as much as we might think. It's slowly drifting away from us, even as we speak. The moon can seem small or large depending on the lunar cycle, but in actuality, it's just over a quarter or 27% of the size of Earth. The diameter of the moon's orbit around us is nearly 477,213 miles, but this diameter is increasing by 1.5 inches every year, which of course means that it's moving away by a factor of 1.5 inches each year. To help explain why we have to analyze our relationship to the moon a bit more closely, both celestial bodies are tidally locked. We are synced up in such a way that we always see the same side of the moon. The hemisphere that we never see is often referred to as the dark side, but that's not quite right. As the moon orbits Earth, different parts are in sunlight or darkness at varying times. This change in illumination is the moon going through its various phases. The tidal forces not only affect our oceans, but the body of the Earth too. Because the Earth is more rigid in structure than water, the tides on more solid matter, like the Earth's crust, have a much smaller effect. The tidal forces are interdependent. The gravitational field of the Earth will also apply tides in the body of the moon. Again, because we're not talking about fluid, the effect is very small, but it's there. This interchange of tides is quite complex. Interiors of both bodies are heated by these tides, just as the force applied to any object can create friction or its own heat. Take the planet Jupiter, for example, and its moon, Io. The tidal forces of the giant planet are so huge that the surface of Io, which is solid, is raised and lowered several hundred feet in each rotational period. The heat generated means that the interior of Io is most likely molten. As a result, the surface of Io is covered with active volcanoes. It's one of the most geologically chaotic places in our solar system. Despite its heat, it's definitely not the place to take the family for a summer holiday. Back to Earth. Our planet rotates on its axis once every 24 hours, and the moon performs one revolution around us in 27.3 days. The bulge on Earth actually speeds up the moon. The Earth pulls the moon ahead in its orbit. In other words, the Earth's bulge increases the radius of the moon's orbit around us. While this is happening, the moon pulls back on the tidal bulge of the Earth, slowing its rotational speed, though just a fraction. A very small fraction. This means that 100 years from now, a day on Earth will be 2 milliseconds longer than it is right now. Blink and you'll miss it. Literally.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.